Okay, we're going to do one of the end of chapter questions that I assigned you in the study guide. I hope you're looking at the handwritten answers that I provide for these because, I go to quite a bit of trouble to prepare these, and I often include extra information over what you might see in the key that you get from Tro. So in this case, I've written down some information from the question. So this is a classic calorimetry question where we have two substances at different temperatures, and we're going to throw them together. So I'm just going to go ahead and write in the heat capacities for water and silver. And you see at the top here, I've calculated delta T for the silver, which is initially warm, and then we're throwing it into water, which is cooler. So because delta T is final minus initial, the final temperature is less than the initial. So that's going to be a negative number. The water is going to be getting warmer. So as we're going to see, when you take a cold thing and a hot thing and you mix them together, one's going to have a positive delta T rather, and the other's going to have a negative delta T. So in this case, the water is going to increase in temperature by 1.4 degrees. The mass of the water is given in the question, and then we have the heat capacity of the water. Over on the silver side, we have delta T, which is negative. We're asked what was the mass of the silver block. And then we also can look up the heat capacity of the silver. So remember, when we're doing calorimetry, we're going to say, okay, heat lost by one thing is gained by another thing. And so we're going to always begin with this expression Q equals Q. In this case, the silver is warm when it starts, so it's going to lose heat. So we're going to give that a sign of negative Q. And then the water is gaining heat, so that's positive Q. So I like to remember this just by the fact that the plus sign means it's gaining heat, the negative sign means it's losing heat. Okay, we know our Q expression because we've seen this already. So Q equals mass times delta T times C. So I'm simply going to go ahead and set these equal to each other. So negative mass of silver times the heat capacity of silver times delta T for the silver equals positive, I'll write a positive here, mass of the water times heat capacity of the water times delta T of the water. Okay, so here we have 6 things to fill in, but one of them we don't know, and that is the mass of the silver. So that's often going to be the case with these questions. You're going to have a whole bunch of variables, and there's going to be one that you don't know, and you plug in and solve for that thing. So in this case, let's see here. I'm going to move this up a little. We're going to have negative mass of silver times 0.235 joules per gram per degree times negative 32.3 degrees equals 4.18 joules over grams times degrees times 100 grams times 1.4 degrees Celsius. Okay, so what's going to cancel? Well, we're going to cancel out the degrees here, and here we're going to cancel out the mass and the temperature. So on the right side, let's see, I went ahead and just solved for this. So go ahead and plug this in to your calculators, and you should get 77.0964 grams. And if we go up here, and look at all of the numbers we started with, we can see that we have one of our numbers which is 1.4 degrees. So that that number is going to limit our final answer to 2 significant figures. So let's go on back down here. We're going to go ahead and round this to 77 grams. Okay, and that is our final answer. If you look at the answer key in TRO, you'll see that in one place they say it's 77.1 and in another it says that it's 77. The correct value is 77. I also have a note here to mention that the signs look weird in the key from TRO. So I recommend that you just look at the key that I wrote that's all handwritten, and hopefully you can follow that. By the way, that key that I just mentioned, I actually worked this from that key. So you can check this question 65 off. If you've watched this little video, then you have essentially done this question.